This chapter is about telecommunications and networking. Telecommunications is a large sector of the global economy, and what's fascinating about it is that it's not new and that it's growing rapidly. Telecommunications has been around since the 1800s with telegraph, and it has evolved very rapidly into wireless radio devices, and even with encryption in the 1920s. And in the 1940s, we even had wireless drones. I like to read World War II history, and I was surprised to find out that someone who is an actor actually worked on wireless drones, assembling them, and was discovered doing that, and then became famous after this. And that person is Marilyn Monroe. Surprisingly, Marilyn Monroe assembled wireless drones for a time during World War II. So anyway, you can look up that history if you want. But telecommunications now on our portable devices are, we oftentimes take it for granted. We have many different ways of communicating through telecommunications with our smartphones. We can do this with cellular. We can do this through Bluetooth. We may use GPS. These are all different telecommunications protocols. So we are all very accustomed. And you can see from this also, as we use our devices more and more, that the demand and the requirements increase. And we all love to have unlimited bandwidth. And so you can see why telecommunications continues to grow today. It's been doing this for over a century. So the opening case talks about how telecommunications companies want to economize, and they make decisions, and sometimes they have to replace equipment. For example, they want to get rid of twisted pair copper wire networks and replace them with IP systems. IP systems is a general term for Internet Protocol systems, which involves packet switching. And because with the Internet, if you can connect something to the Internet, then you have accessibility to all kinds of different services. Section 6.1 asks, what is a computer network? And it's springboard for a lot of terminology, some basic telecommunications terminology and the different types of networks. So we have bandwidth, for example. Bandwidth is the carrying capacity of a medium. For example, a twisted pair wire, as I mentioned, or fiber optics. They will have different bandwidths. Also, if you use microwave through the air or radio, it depends on what you're doing with telecommunications as to what the bandwidth is. When we have very high bandwidth, a lot of carrying capacity, we call this broadband. So broadband is a relative term. What is broadband today will not be broadband 20 years from now. So broadband is a transmission capacity of communications medium that is very fast. Then your book talks about 3 different types of networks, ways of classifying them. One is a local area network. For example, your school's main campus, your high school's main campus network could be a LAN. We have a LAN or local area network in our department. We have a local area network for our college as well. So usually a LAN fits in a building. Then we have wide area networks. A wide area network, or WAN, is a network that isn't contiguous. For example, the internet is a WAN, and we can oftentimes use your imagination about how to configure this. A WAN can go between buildings, and all of these networks are going to rely on routers. A WAN will be a combination of different LANs and printers and other devices, whereas a LAN will be confined to a building or a room. Then we have enterprise networks. This is a backbone network for a company, a large corporation. For example, you can have a company with 20 different offices in one big city, and you'll need to connect them. and you'll need to create a firewall to protect it from the outside so that only your people are communicating with each other. This would be an enterprise network. We also have personal area networks. A personal area network is something that you may have experience with if you have a Fitbit, or if you've used the Wii. Usually PANs are associated with Bluetooth. So you would have a device and it will talk to another device. If you've ever had a peripheral device like a heart rate monitor for your phone that would connect with Bluetooth to your phone, then that would be a PAN. PANs have a great deal of promise for monitoring people's health, especially the elderly. But we see this in our smartphone apps more and more these days. So we have, in order of smallest to largest, we have the PAN, the personal area network, the LAN, then we have a MAN, which is a municipal area network. That's focusing on a city. Then we have a WAN. WAN is more associated with the internet or largest applications. Section 6.2 is about network fundamentals. This is where we get into more detail about networking. Anytime you talk about networking, you're going to talk about communications, media, and channels. For example, wireline versus cable media. And then you have wirelessness as well. So we're going to talk about some of the media, the physical media that we use. Here is a great depiction of the type of transmission media that we're talking about. It has a picture of each one. It shows how each one is built, and it also gives a comparison of the performance of them. For example, twisted pair wire is relatively inexpensive to purchase. However, it's subject to interference. That's a disadvantage of twisted pair wire. It is also the most prevalent form of communications wiring. It is something that's probably less desirable because it has limits to carrying capacity, but this is the transmission media that we used for telephone for about 100 years. We still have a lot of twisted pair that exists in homes today. Also, is coaxial cable. This is associated with cable modems. It gives access to the internet through your TV connection in modern times. We also have fiber optics, which is the fastest way to transmit. It has the highest bandwidth. However, fiber optic is also the most difficult to splice and to work with, to modify. Twisted pair is the easiest. Fiber optic is, because it's higher in maintenance, it's going to be more expensive in the long run, but it has the greater performance. And coaxial cable is kind of in between on cost as well as performance. So this is the types of network processing, and economics drives all of these changes. So decades ago, somebody decided, well, we can actually, instead of having 20 computers in one room or in one department, we can actually, save a lot of money. Instead of buying 20 printers for those computers, we can buy one printer and have 20 computers share that one printer. But how are we going to do this? We would do this with networking, with a local area network. And so what we need to do is have devices that are subject to potentially more powerful devices. We can also have a larger computer that would distribute files to smaller computers. And so they created the client-server computing environment. The client is a smaller computer usually, and the server is a larger computer. So even in the early days of networking, we would have a word processor on a large computer, and we would download the files as needed to the clients. So in this configuration, one computer is more powerful than another computer. It was a tremendous economic boon to networking and computing when this was first created. Different from this is the peer-to-peer processing approach. In this case, computers act as peers. In other words, we don't know which one is going to be more powerful at any given amount of time. For example, if you've ever used BitTorrent as an example of P2P, It's open source, free, and it involves file sharing. And so BitTorrent means with this protocol, we go and get a movie, and that movie may be resident on 20 different machines, and those machines will all be requested. We'll make a request for all of them, and the files will be reassembled. So if you've done P2P file sharing, you can see this configuration. You don't know which computer or which node is going to be serving the files or playing the role of client at any given time. So that's why we call it peer-to-peer processing. This is an important slide because it talks about the protocol used by the entire internet. It is called the TCP/IP protocol, or Transmission Control Protocol / Internet Protocol, and it runs on something called packet switching, and I'll describe what that is because it's important to know this, because anytime we use internet, we are using packet switching, whether that be for telephone calls through Skype or email, sending a video, downloading a video, streaming, anything is packet switching. It's important to know that because that has security implications. And so I'll show you that from here. You see this message begins in New York City, and it has packets P1 through P6. And this will be representative of, let's say, a video. And you can see from this that each packet takes a different route to the destination in Los Angeles. So for example, P1 goes to Chicago and then Los Angeles. P4, on the other hand, the pink one, goes from Chicago to Dallas and then to Los Angeles. P3 goes from Atlanta straight to Los Angeles. And you can't predict where the different paths of any given packet. But when it gets to Los Angeles, it is reassembled in the exact same order. And so that is packet switching. And if it doesn't, you don't have all the components, then the message is sent back to the sender that that the message was not sent. So this is called fault tolerance. And it's important to note that if you send a message, for example, your social security number, an email, you don't know what computers are going to handle this message. And people do put sniffers on their nodes, their internet nodes, for certain data types. So if you send a credit card number, social security number over the internet, someone could scrape it with a script. So don't do that. So that includes anything, whether you're using chat or anything. So that is TCP/IP, which is the Internet's protocol. It includes everything we do in the Internet, including email, hypertexting, anything that we do, any kind of protocol. That's the Internet. That would be a wide area network protocol. I should also point out the most common local area protocol is called Ethernet. It's an IBM protocol for local area networks. So both of these are really important protocols. They are rules of engagement between computers. Any protocol has layers. For example, the application protocol is one of those layers. An example of this is SMTP, which is Simple Mail Transfer Protocol. The application protocol enables client application programs to access other layers. Another example is the network interface protocol, which places packets on and receives them from the network medium. This brings us to various network options. Listed here are the different options for networking, and we usually associate this with computer networking, with the internet access. But at one time, it was highly innovative to be able to just use the telephone. We had dial-up, still used heavily in the United States. It has historically been an analog network, and use twisted pair. This is not so optimal for internet access. So they created DSL, which is the digital subscribers line. This is a paid service, and it was an attempt to gain access to broadband communications. So it facilitated computing because it was digital as well. And because people wanted to have access to television shows, featured content, sitcoms, movies, anything video, where they would just watch, they came out with cable modem about 50 years ago. This gives access to many video channels over a cable, and so it was had tremendous bandwidth capacity for the time, and we still have it today. It had such good bandwidth that the temptation was to use it for the internet at one time. So some of you may still have cable modem today. Then we have a satellite as well. Satellite, we use this for XM radio, we use it for GPS, we use it for to replace cable modems as well. So we want to access movies as well through satellite. It has the problem of line of sight communications. And then the general term of wirelessness. Wirelessness is very convenient. We have this thing called WiMAX, which is an overarching wireless capability. It's not associated with satellite, though. It's usually using resources on the ground, and we want large coverage, so we have these very powerful transmitters for wirelessness. Again, it may have the problem of line of sight transmission. Then we have fiber to the home. This is more modern. A lot of you have subscriptions to fiber to the home. This was a new thing about 5 or 6 years ago in Starkville. It's more expensive, and it's usually placed only in new housing developments, but a lot of college students probably wouldn't tolerate much more or much less than fiber to the home. And you see that it's going to be fiber optic, and it's going to have much higher bandwidth. It's going to be a little higher to maintain as well, but we nowadays have made it more economical. For many years they knew about fiber to the home, but it simply was not economical. This great company called C-Spire was able to figure out how to make it economical, and the rest is history, at least in Mississippi. Section 6.3 differentiates between the Internet and the World Wide Web. The Internet is a network of networks. It is a protocol with multiple layers allowing computers to talk to one another. If you adhere to the TCP/IP protocol, you can join the Internet. You can join any device, any digital device, to the Internet, including a television, a toaster, an automobile. And that is because you have adhered to that protocol, that series of rules where we engage in other computers. The Internet comprises of a backbone, and that backbone is simply the fastest routers that make up the Internet. And those routers, we're going to rely on them more than any others for transmission capacity. There are two basic ways to configure the Internet in a closed way. One is the intranet. An intranet is a walled off, closed network that utilizes the TCP/IP, utilizes Internet technology. And why we do this is for economics, again, because we know what languages to use. We have trained people in the workforce who can work in this environment, the Internet environment. And so examples of an intranet are Banner and Canvas. When you download this video, you're using using an intranet, because that's what Canvas is. And note that not everyone in the world can download the video because it's closed off from the rest of the world. You have to log in. And it is an MSU specific presence. We subscribe to Canvas so that we can use that internet-based application. Also are extranets. An extranet means that you can connect from one organization to another. For example, VPN or virtual private networks are a form of an extranet. And again, this is private as well, just as the intranet is. And then there's this wide open form of the internet. We have network access points, or NAPs. These are exchange points for internet traffic. And we have this many-to-many relationship between all of these computers. And we need a rule of engagement for that as well. We call this the World Wide Web. These are aspects of the World Wide Web that have become really popular. One is hypertext, where you click on things. The idea of websites. And to access a website, you would use a uniform resource locator. That is simply a long name for a web address. So you can see from this that the World Wide Web, or the WWW, is not the same thing as the Internet. The World Wide Web is how we use the Internet, and the Internet is a large number of networks connected to one another. The fundamental rule about information on the web is user beware. That is because when we access information, presumably we intend to do so because we are using commands and clicks and so forth. So we have to be aware of what we're doing on the internet because the liability may lie on us. Your chapter contains two cases in this section. One is it's about business Google Fiber. In this case, Google is installing and operating ultra-fast fiber optic cable service. Google's main business reason for installing fiber in select U.S. cities is to generate more web traffic, which generates more ad revenue for them. So Google has a business model where they receive more usage and they get more attention and they can place ads and gain revenue. It's worked so well that they are one of the few companies that have reached $1 trillion in capitalization. Actually, it's its parent company called Alphabet. The next case is about the tight controls on internet access in Cuba. The internet in Cuba is among the most tightly controlled in the world because it's a communist country. Cuban citizens primarily have access to an intranet. To access the internet illegally, Cuban citizens can share user accounts. So you can see they still try to bypass the legislation so they can have the accessing freedom that everyone else has. It's interesting how the cultures and the national treatments of the internet are very different. Section 6.4 is on discovery network applications. This is another category of applications. For example, a search engine. A search engine indexes pages updated by web crawlers to provide fast searches. A lot of people may not realize, but when you do a web search, you're actually interacting with an index file that's already been created. And meta search engine is a combination of search engines. For example, you can go to Metacrawler or Dogpile, and 37.com, for example. 37.com is self-explanatory. It's a combination of 37 separate search engines, and it's under one interface. So you do one search, and you're actually doing 37 separate searches. The reason meta search engines are necessary is because no search engine can contain all of the information on the internet at any given time. So you use Google heavily, but it only sees about 50 to 60% of the information on the internet. And so it's just going to be, for some people, it's not as useful as they would like. So they use meta search engines. And of course, meta search engines may be more comprehensive, but they may not provide the more logical results. So we may go back over to something that's more user-friendly to us, such as Google or Yahoo. When we use search engines, what becomes important is the different languages that are represented in the world, publication of material in foreign languages. So, for example, the United States Olympic team will have a website, and they be in English. English is predominantly our language. But if you want to reach out to people in Japan and Israel and Russia, you need to have material published in foreign languages as well. So the U.S. Olympic Committee would certainly have to deal with that as well. Another way of reaching information on the internet is through portals. A portal is simply a gateway to content on the internet. Usually a portal has predefined categories of information. For example, there are commercial portals such as Lycos and Yahoo, and they will give you specific categories of information. For instance, if you're interested in movies, you click on their movies link, and it will prescribe certain movies, and they will try to make a user-friendly interface to that. And that is different from a search engine. A search engine is a very simple interface where you search for you do all custom searches, but a commercial portal will try to direct you to specific content. We also have affinity portals. For example, you can go to the MSU's web page, or you can go to ESPN.com, and you love MSU, or you love ESPN, or you love the U.S. Olympic team, and something that you love. Maybe you love U.S. veterans, and you want to support them. So you go where you love things, and you will have a portal where you can access content that way as well. For example, if you may have a favorite team. We also have corporate portals. A corporate portal is for critical business information inside and outside an organization. It's probably going to be in the format of an intranet, where we, just like banner or canvas, but it's going to be, corporate news. It's going to be corporate email. Everything you would see in a corporate portal, but it's going to be just for your company. Maybe even weather for the specific locations of your company. Articles that are pertinent to your job. And a corporate portal will also provide only content that is necessary for doing your job. For example, if you're an accountant, it will customize content for you. Then we have industry-wide portals as well. For example, TruckNet was created in case trucks drop their delivery orders. In other words, if they get a flat tire and they can't make the delivery, they may call another truck. It was so that the industry could function better. Section 6.5 is about communication network applications. In other words, there are applications just so people can communicate. Of course, we've all used electronic mail. Email remains the largest volume application running over the internet. Also, our web-based call centers. Many of you have interacted with these when you had a problem, maybe with your Xbox or some laptop or something. You call some number, and because of the internet, its far reach, you may talk to someone in Pakistan. We've all had these experiences, and of course, this is an economic matter. You can spend more money to have a call center in a large U.S. city versus, like Manhattan versus some small town in West Virginia. These web-based call centers are set up such that it's economical and user-friendly for everyone. Sometimes they succeed and sometimes they don't, but that's their challenge. Electronic chat rooms also very similar. We can do troubleshooting through chat rooms as well. It's another type of protocol that we use on the internet. Also, voice communications. Many of us have used Skype. That would be internet telephony. A lot of people are using Zoom now. It's exploding right now. And all of this uses the TCP/IP protocol. VoIP is another one. People are now beginning to telecommute more than ever. I have a neighbor who's telecommuting, has been telecommuting for 20 years. These are knowledge workers that are being called a distributed workforce. And it's enabled by telecommunications technology, which of course the internet is the backbone of that. Telecommunications has pros and cons. For example, presumably it's reduced stress. That's one of the benefits. Less gasoline usage, less automobile depreciation expense, less office space. So, these are some the benefits of telecommuting. But security is also a disadvantage of telecommuting for employers, because now you have this networked component that you didn't have before, so you have another layer of concern for your security. This chapter contains a case called Get Rid of Email Seriously. To increase employee productivity, Atos actually banned email. In other words, they banned a productivity tool to increase their productivity. So this is another great example of how management has to make economic decisions regarding the function of their organization. They actually had an initiative called Atos Zero Email Initiative. So that was something they did internally to their company. Section 6.6 is about collaboration applications. Collaboration is going to involve work groups, groups of people, and this can be permanent work groups or temporary work groups. We are finding that more and more often organizations are facilitating more temporary work groups as well. The challenge is to use the internet to enable workflows that can be very complicated using rich information. Workflow is the movement of information as it progresses through the sequence of steps that make up an organization's work procedures. And so all organizations have procedures and workflows. When you exchange documents with co-workers through organization-approved methods, for example, this is considered workflow. Workflow is usually handled by virtual groups these days. Virtual can mean a couple of things, and usually they're related, but it can mean not only internet mediated or network mediated, in other words, everyone isn't necessarily in the same place at the same time, but it can also mean a temporary group or team. We see virtual groups throughout industrial history, the movie industry, for example, in addition to collaborations on songs, and for our purposes, software as well. We use virtual project groups for lots of work. In fact, it's probably more popular than it's ever been. So this brings us to virtual collaboration. And so this may be something you've done. If you've used Google Drive to work on a document with a classmate, this is considered virtual collaboration. So organizations have learned to leverage collaboration techniques. So one of these is crowdsourcing. And your chapter gives a good example of crowdsourcing with Doritos. Doritos had created a Super Bowl commercial through collaboration with customers. So this is a good example of crowdsourcing. Your book also talks about electronic teleconferencing and video conferencing. A more recent innovation of video conferencing is Telepresence. This is where we can have telecommunications mediated conferences any place, anywhere. For example, you can go pump gas and talk to the gas station attendant through video interfacing, through telepresence. You can be driving down the road in your car and access someone on a video camera. You can use your imagination. You can telepresence with anyone, anywhere, at any time, as long as you have the technology to do it. And by the time you retire, telepresence will be very prominent in society. This slide shows technologies that are used in telepresence. The two Segway machines on the top right are kind of comical, but it shows how we can actually come together in as rich a way as possible using technology. In this case, it's mobile technology that could drive around, assuming you could control the devices, remote control. So it's kind of a funny way of looking at it. Who knows? It could be happening somewhere. But to the bottom left is a little bit more of a serious depiction of telepresence technology. You see a conference table with the monitors, and the attempt is to sit there and make it appear as rich as possible, as though you were sitting there with someone else. And of course, this is going to save a tremendous amount of money if you meet a lot internationally, maybe buying and selling from foreign countries. where you save a lot of money on hotel bills and air flights and other costs. A lot of fuel. So all you need to do is coordinate the times, and you can meet with someone in as rich a environment as possible. So telepresence requires dedicated rooms, and costs have decreased in the last 10 years. And again, it's economics that is driving this. Section 6.7 is about educational network applications. And by now, you're very familiar with e-learning because you're doing it right now. E-learning does not necessarily completely replace the classroom setting, but as you can see with technology, we can do the best that we can. E-learning refers to learning supported by the web. E-learning is outstanding for certain purposes. It can be used greatly for foundational courses such as this, for analytics instruction, for programming, and if done well, you can teach anything very well over the internet. So computer literacy is a drawback of e-learning because sometimes people don't necessarily have the computer literacy to do it. Maybe not you, but of course worldwide it's going to be a limiting. And of course that reminds us of the digital divide. Not everyone has the resources to participate in e-learning. Interaction is also a drawback of e-learning. There's not as much interaction, rich interaction. We can have message boards, but there's nothing like face-to-face. Learning time is a benefit of e-learning in that you can actually listen to videos, watch videos wherever and whenever you want, and you can just opt not to do so. Cost is also a benefit of e-learning. It can be a lot more cost beneficial because of less travel. You don't have to spend any time traveling for e-learning. So distance learning is supported by networking applications as well. We now have virtual universities. Phoenix University actually named a stadium in Phoenix. Actually, it's not Phoenix. It was in Arizona. The Arizona Cardinals played in the Phoenix University Stadium. So that tells you the kind of real impact that virtual universities can have. There's a section closing case called It's About Business Massive Open Online Courses. And so the vision here is that you would have an outstanding teacher, a famous teacher, who is just dazzling and wonderful. And that person would be very popular. And you could facilitate this with telecommunications through educational applications. And so one advantage of this is if you have a massive group of people, you you will not have the ability to field questions from anybody at any time. And so what you would do is you would filter the student questions. You may get a GA or someone to do this. In this process, you actually are able to address the most pertinent questions. That can actually be an advantage of the massive open online courses, or MOOCs. And there are many other cost efficiency advantages as well. The chapter closing case is about network neutrality. This means that internet service providers must allow customers equal access to content and applications regardless of the source of the nature of the content. Possibilities of censorship is an argument for network neutrality. In other words, the people who are for network neutrality don't want any kind of manipulation of service, and they want everyone to be treated the same regardless of how much they're paying and how many resources they have and what neighborhood it is, or whether or not they have a more powerful machine. And this is becoming more and more important in neighborhoods as, for example, in my neighborhood years ago, AT&T came out with DSL, and we were so ecstatic to have it. But as time went by, guess what they did? They gave some of our bandwidth to another neighborhood just because they got us all to subscribe, and they were trying to open up business in that other neighborhood. Well, thankfully, fiber to the home, eradicated that. So, but you can see how commercial interests will interfere with, prior obligations. But the FCC has been both a supporter and not supporter of networks and neutrality over the years. So this concludes our chapter on telecommunications and networking. This is chapter 6. Thank you.